Good afternoon, class. Today I want to discuss with you the factors which affect the distribution of temperature all over the world. Altogether, we have 8 factors. The first factor is latitude. Let us draw a small globe which will represent the Earth. Now, we have different latitudes which are imaginary lines or angular distances from the equator, north or south of the equator. Suppose this is the equator. The Greeks had divided the Earth into 5 heat zones: a torrid zone in the equatorial region, 2 temperate zones, and 2 frigid zones. So the areas which lie in the torrid zone are the hottest because they receive the maximum insolation throughout the year. One, because they are vertically receiving the sun's rays. Secondly, because they are receiving it for the highest duration. Okay, so and as we go up towards the poles, the temperatures increases normally. There are so many other factors which will influence this temperature. Next is altitude. Suppose we have different types of landforms. We have mountains, plateaus. Let us take this example. There's a plain area A, and in the neighborhood there is a mountainous region B. So when we compare these two regions, taking into consideration the normal lapse rate, when the sun's insolation, shortwave radiation falls on the earth, it is reflected again as terrestrial long wave radiation. So the earth gets heated, the valleys get heated, and this radiation which goes back, in the process it loses some heat, and because of this normal lapse rate takes place, means temperature decreases at the rate of 6.5 degrees Celsius for every 1 kilometer or 1000 meters. So the temperature in B will be much lesser. Suppose B is at a height of 1000 meters and A has a temperature of 32.5 degrees Celsius. Then what will be the temperature of B? Okay, that is your assignment. Now we can explain, because of this the temperatures of Imphal is much higher than the temperatures of Ukhrul and Mau. Okay, now coming to the next factor, distance from the sea. Now the areas, these are the coast, okay, the coast which are surrounded by the seas and oceans. These areas, they normally have moderate temperatures which are neither very high nor very cold. Why is this? Because the sea breeze comes towards the land, moderating the temperature during the daytime, and the land breeze blows from the land towards the sea, moderating the sea temperature. This is because the land and the seas, they are receiving heat unequally. Land gets heated fast, water gets heated slowly. So the air flows from the cooler place to the warmer place. Okay, so there's a sea breeze in the daytime from the oceans to the land. So because of this phenomena, the temperatures are moderate. That is why we can explain Mumbai has an average temperature of about 25 degrees Celsius to 35 degrees Celsius. It is rarely above 35 degrees Celsius all throughout the year. Now next factor is nature of land and water. We have just discussed one of the characteristics of land and water. We have other characteristics because this land and water, they have different characteristics of receiving insolation. Mainly because the land is opaque and water is transparent. Here in the ground or the land surfaces, insolation penetrates up to a depth of 3 feet. So it does not penetrate much beneath this level. So because of that, it loses this heat very fast. It doesn't take time to lose this heat very fast. Because of this, as soon as the sun sets, it loses all the heat, and under clear skies, this heat is totally lost. But in the seas and oceans, because it's transparent, the insolation reaches to very deep levels. Okay, so because of that, it is difficult to lose this heat fast. Then the next factor is rate of evaporation. Now rate of evaporation is higher in the oceans because it is full of water bodies, because it is full of water. So because of the rate of evaporation is higher, most of the heat which comes from the sun, it is spent on evaporation. So temperatures are normally lower over the oceans, okay, and temperatures are higher over the land, okay, because of the rate of evaporation. Then next is greater specific heat of water. Now we have 2 equal volumes of water and land. Let us say 1 cubic foot. okay, 1 cubic foot of land and water. Now it will require twice as much heat to heat them to equal temperatures. Okay, twice as much heat of land to heat water. The specific heat of water is more. So it takes longer time for water to be heated. So because of this also, the land gets heated fast and the water gets heated slowly. Now we come to the next factor, nature of ground slope. You see different ground slopes, ground surfaces over the earth. You see land, you see trees, you see vegetation, you see some snow covered places. So we have different areas, suppose mountain tops, we have plateaus, we have forests, okay, we have concrete settlements. Now these are the different land features. Now the rate of deflection of insolation, that is albedo. Okay, how much insolation is again radiated or deflected by the surface, that is known as albedo. The albedo of the snow covered places is very high. It is almost 70 to 80%. Whereas the albedo of water is very less. It is about 3 to 5%. Of land, it varies from 10 to 15%. So depending on the albedo, suppose the snow covered surface which reflect about 70% of the solar energy, then only 30% remains with them. Okay, that is also again re-radiated back as long wave terrestrial radiation. Okay, so that is why. And another factor is there is a difference of insolation in light colored surfaces and dark colored surfaces. Just like we have light colored clothes and dark colored clothes, we are suggested to wear light colored clothes in summer because we do not absorb the heat. Okay, but dark colored clothes, we absorb heat. So similarly, dark colored surfaces, they absorb more heat than light colored surfaces. We can compare, say, dark colored soils, okay, dark colored soils and light colored soils. So definitely dark colored soils will have more temperature. Now next, nature of ground slope. Now this is another important factor. Suppose this is our earth. Most of the mountain ranges we see on the earth, they are extended in this manner. They radiate from east to west. Okay, they extend from east to west. And suppose the sun which falls on them is able to heat only the southern slopes. Okay, the southern slopes are properly heated, but the northern slopes do not receive sunlight directly. So these are known as the shadow regions or the leeward slopes. So the temperatures are higher in the southern slopes, but temperatures are very much lower in the northern slopes, though they are very close to each other. So that also determines how much of temperature is received by the place. Now next, the prevailing winds. Now the winds which blow from cold places to warm places. The destination, the place of origin. Okay, first the place of origin and the destination. Suppose if the place of origin is a cold place and they blow into a warm place, they will decrease the temperature of their destination, and vice versa. Suppose if they are blowing from a warm place and they come to a cold place, then they will make the temperature a little higher in the cold regions. Okay, the same is with ocean currents. Now we have 2/3 of the earth's surface covered by water, so they have a great influence on the temperature distribution. Now the places which lie near to the cold currents, they become warmer or have lesser temperature, and those places which have warm currents close to them, they have higher temperature. We can take the example of Kuroshio current. Kuroshio current is a warm current, okay, and this brings in warm temperature to the place that it visits. Okay, so we have 8 factors which influence the distribution of temperature. Then in the next class, we will go to the air pressure and winds.